Everybody, in this video we're going to be discussing the parent cubing function, the cubic function. So we're going to start by taking a look up here. The cubing function is any function that is of the form y equals x cubed, but the most perfect cubing function would be this one here before we've transformed it. So let's go ahead and start by taking a look at the picture, as a matter of fact, okay, of the graph. So head over to Geogebra, head down to the input field. We need to type in y equals x cubed, so we do have to use a caret on this. We'll go ahead and hit enter. Notice that shows up here in the middle, okay, so let's go ahead and shift things around a little bit. I want this to show up a little bit more clearly, so we'll right click on it, go to object properties, change its thickness maybe a little bit, and maybe change its color to like an orange. But I want to go ahead and copy this, so I'll click and drag around it. We'll hit shift command C or shift control C if you're on a PC, and I'll go ahead and paste this in right over here into our Photoshop canvas, so I don't need it to be too big. But what I want you to see, I will bury it over here. Very good with that right there. But just talk about the shape of this graph and its characteristics. But first things first, I say the shape of this graph looks like John Travolta in the movie Saturday Night Fever. This is kind of a stupid joke, but it's kind of how I remember it here. You know, if you've ever seen the movie, I'm really sorry. I've seen it too. And if you haven't seen the movie, you just need to know that he's pulling a sweet dance move, but it kind of reminds you of this graph over here. So as far as this graph goes, we need to mention a few things about it. The shape of the graph looks like, you know, John Travolta, but the domain. All x values work in this function, so you can always plug in an x value, cube it, and get an output. So you'll notice the domain is all real numbers on the x-axis interval from negative infinity up to infinity, so all x values work. And as far as range goes, range is also negative infinity to infinity on the y-axis. It covers all y values, okay? We say this is an odd function. Odd functions just mean this, if you are odd, okay? It doesn't mean that you're weird. It just means that this is the definition of an odd function. Given a function f of x, if we were to, say, plug in a negative into the function right there, you actually get negative of what you started with. So you get the exact opposite of what you would start with. And so in this instance, I want you to see this. If I were to put in negative x into this function, well, it was x cubed. We'll take out the x. We'll put in a negative x everywhere I see one. But notice that when I cube a negative, I actually get this negative x cubed. And x cubed, hey, this part right here, is the same as just f of x. So I get negative the thing I started with. So when we plugged in a negative into the function, I got negative everything that I started with. Okay, so it just basically reverses our function. Everything switches its sign. The thing about odd functions is that they're symmetric with respect to the origin or about the line y equals x. And just to show you this here, if I were to go back over to Geogebra and graph and y equals x, you can see that my graph is symmetric about the origin. Okay, symmetric about the origin, about that line. All right, so heading back over here, we also say the graph has an intercept at 0, 0. This is very important. All the parent functions we've talked about so far, y equals x, you know. Let me show you y equals x. You know, if we graph y equals x, it has an intercept at 0, 0. And if I were to graph y equals x squared, you know, here's our parabola function. Check this out. They all go through 0, 0. So keep this in mind with your parent functions. Notice that they all go through this point 1, 1 also, okay? So up 1, right 1. Just keep that in mind. Good thing to know. And then you just have to memorize the basic shape of the graph after that. But the last thing we want to note on this graph is that it's always increasing. You know, we say always going uphill. And so from left to right, if it's always going uphill, then we would say it's increasing on the x-axis interval from negative infinity to infinity.